Hi everyone, welcome to Sravanthi Academy. Let's understand mathematics. Hi everyone, today we will start 18 tangents and intersecting chords. In this chapter, we have to learn circles properties also. Already before videos, we learned circles properties, how to use that properties and all. Here also we have to use that same properties and extra properties also we have to learn from this chapter. So what properties we can use here? First, we have to take one line and circle. Observe this. This is one circle and this is one line. These two are not intersecting. Intersecting means what it will happen. This line is intersecting this circle at 2 points. This is 1 point and this is 1 point. This type of circles we can call secant of the circle. Secant of the circle. Next, this is one circle. This line is intersecting at 1 point on the circle. Here you should observe circle is intersecting at 1 point. This we can call tangent. Tangent. You should observe this line is intersecting circle at 1 point. Where is intersecting? That we can call point of contact. Point of contact. Next, one more. Here we should observe this is circle. This is center of the circle. This is radius. What is this? Tangent. AB is the tangent. OC is the radius. Tangent to radius always perpendicular lines. Why perpendicular line? Perpendicular line means 90 degrees it will come. Exactly 90 degrees it will come. This is tangent and this is radius. If you will take any one line, see side here, if you will take any one extra line here, that is not exactly 90 degrees to this circle. Here also same thing. Any line we can take parallel to OC, but that is not exactly 90 degrees to the tangent. So OC is 90 degrees. OC and AB are 90 degrees, perpendicular lines. Next, one more. We have to draw one circle. We have to consider one point, external point to the circle. We have to draw two tangents from the circle to the point. This is A and this is B. This is some point P we have to consider. This is center of the circle O. When we have to draw these two tangents to the circle, the two tangents equal it will come. Why equal it will come? We have one theorem. See, in this ICSE syllabus, proofs they won't ask in board exams. Just we have to learn properties. We have to observe this. How many triangles it will form here? Two triangles, AOP one triangle and BOP two triangles. These two triangles similar we have to prove. Similar condition means similar or congruency. Congruency means corresponding angles are equal, corresponding sides are equal. First we have to observe here AP and OB both are perpendicular lines from this diagram. So this is 90 degrees it will come. One angle we got. Next, here OP is the common side. Next, OA and OB both are radius. Here one side, one angle and this is side. Side RHS theorem we have to use. RHS theorem proved. So these two triangles are say congruency we can prove. Congruency. Congruency means corresponding sides are equal. What sides equal it here? Here AP and AP is equal to BP. So these two tangents equal it will come. These properties we can use next exercise and circles properties also we can use. Now we have to start exercise 18A. First main total 5 MCQs are there. First problem we have to solve here. First here PA, PB, Q are tangents to this circle. Here PA, PB touching at one point to the circle. Here QR also touching at one point on the circle. This we can see, take C. If perimeter triangle PQR 18 centimeter, PQR, this triangle we have to consider. Perimeter means sum of all sides is equal to 18 centimeters. Here length, PA length we have to find out. First given conditions we have to take. Triangle PQR is equal to 18 centimeters. Triangle PQR means sum of all sides, PQ plus QR plus PR. PQ plus QR plus PR is equal to 18 centimeters. First we have to observe here. Here RC and RA both are tangent to the circle. Tangent to this external point, if you have field, means RC is equal to RA. Introduction time we did that. Here RC is equal to RA. Next here QB is equal to QC. QB equal to QC. Now RQ plus what we can write? RC plus QC. PQ plus here QR plus here these two sides we have to take. QC plus RC plus PR is equal to 18 centimeters. PQ plus here PQ plus QB we need. That time only we will get PB. QB how much it will, how it will come? Here QC is equal to QB. So QC I will write here. This is one bracket. Remaining two one bracket we have to take PR. Here PQ plus QC plus what we can write? QB plus here RC plus RA we can write. RA plus PR is equal to 18 centimeters. We should observe this diagram. PQ plus QB. PQ plus QB. Total we can write PB. PB plus here RA. RA plus PR. Both we can write PA. PA is equal to 18 centimeters. Here PB plus PA. We should observe from this diagram what we can say. PA and PB are tangents to the circle. Both are equal. PA is equal to PB. Here PA side we want. So instead of PB plus we can write PA. PA plus PA is equal to 18 centimeter. 2 PA is equal to 18 centimeter. PA is equal to 18 by 2. 2 1 just 2 9 just. PA is equal to 9 centimeters. PA side is 9 centimeters. Here 9 centimeters it will come. Next, first main C problem. Here ABC triangle is there. Here some sides also we have. We have to find out length of AB. AB length we have to find out. This AB length, how to find out? What formula we have to use here? You should observe here AC one side. Total we have to add 9 plus 6, 15 it will come. Next BC, 6 plus 2, 8 it will come. Here 90 degrees they mentioned. 90 degrees means what theorem we can use? Pythagoras theorem we can use. 90 degrees opposite side is the hypotenuse and remaining two sides. Triangle ABC. Angle C is equal to 90 degrees. Pythagoras theorem. Pythagoras theorem. Square of the hypotenuse AB square is equal to sum of the remaining sum of the squares of remaining two sides. AC square plus BC square. Here AC. AC means how to find out? Here some EF you should take. AE plus EC. AE plus EC. Here 9 plus 6. 15 it will come. Here 15 square plus BC. BC means BF plus FC. BC is equal to BF plus FC. BF is 2 plus FC is 6. Here 8 it will come. 8 square. 15 just 225 plus 8 just 64. Here 982. AB square. AB square is equal to 289 is the perfect square. 17 square it will come. Square root cancel. AB is equal to 17 centimeters. AB equal to 17 centimeters. Next, first main B problem. Here we have to observe first diagram. APB is tangent to the inner circle. This is inner circle. This is AB is the chord. This is chord tangent to the circle. Inner circle tangent is AB. Next, chord of the outer circle. This is outer circle. This is the chord of this circle. Next, both circles are concentric circle. Concentric circles means same center and different radius of the circles. Next, if OA is equal to 10 centimeters, OA is equal to 10 centimeters. Next, OP equal to 6 centimeters. Here 6 centimeters. Find AB. Find AP. AP we have to find out. This AP we have to find out. We have to observe here. AP is the tangent. OP is the radius. Here AB only, because first we have to find out AP. Next, here AP is equal to BP. Both we have to add. First, how to find out what theorem we can use here? Pythagoras theorem we can use. 90 degrees opposite side is the hypotenuse. Square sum of the squares of remaining two sides. Here square of the hypotenuse triangle APO. Angle P is equal to 90 degrees. Pythagoras theorem. Pythagoras theorem. Square of the hypotenuse OP OA square is equal to sum of the squares of remaining two sides. AP square plus OP square. OA square. OA square means 10 square is equal to PA. PA we have to find out, plus OP means 6. 6 square. Here 100 is equal to PA square plus 36. Here PA square is equal to 100 minus 36. Here PA square is equal to, here 10 minus 6, 4, 64. Here 64 is the perfect square. What is the perfect square? 8 square it will come. Square, square cancel. Here PA is equal to 8 centimeters. Here only PA is 8 centimeters. But we want AB. AB means how to write? AB is equal to AP plus BP. AP plus BP. AP how much? 8 centimeters. So BP. AP is equal to BP. Here 8 centimeters. 8 plus 8, 60 centimeters. AB equal to 60 centimeters. Next, first main D problem. Here BC is the tangent. BC is the tangent and OD is the radius. If angle DOC, they have given 100 degrees. 100 degrees. Here we have to find out angle B. This angle we have to find out. First we have to observe ACB is a right angle triangle. Why right angle triangle? Here BC is the tangent and OC is the radius. Radius and tangent always perpendicular lines. This is 90 degrees. This angle we have to find out. So this angle we know means angle some property we can use. But this angle how to find out? First OD is the radius, OA is the radius. Two sides equal. This side, this side. DOA triangle we have to observe. Two sides equal means opposite angles are equal. This angle equal it will come. This is X, and this is x it will come. Here AOC is the straight line. Straight line means this is 180 degrees. Here already 100 is there. This is 80 degrees it will come. Here DOA triangle we have to take and find out x angle. Here AOC is straight line or diameter. Straight line angle DOC plus angle DOA. DOA is equal to 180 degrees. Here DOC already they have given 100 degrees. 100 degrees plus angle DOA is equal to 180 degrees. Here angle DOA is equal to this 100 we have to send right side, 180 minus 100 degrees. 80 degrees it will come. Angle DOA. Here 80 degrees. Now we have to consider DOA. Triangle DOA. Angle D plus angle O plus angle A is equal to 180 degrees. Angle sum property. Angle sum property. Here angle D means X plus angle A. O how much? 80 degrees plus angle A is X is equal to 180 degrees. Here X plus X 2X plus here 80 we have to send right side, 180 minus 80. 2x is equal to 100 it will come. X is equal to 100 by 2, 50 degrees. Here x is equal to 50 degrees. What is x? Angle D and angle A. So angle A is equal to 50 degrees. This angle we want. Here 50 degrees and here 50 degrees. Now we have to consider ACB triangle. Triangle ACB. Angle A plus angle C plus angle B is equal to 180 degrees. Angle A how much? 50 degrees plus angle C 90 degrees plus angle B we have to find out 180 degrees. Here 140 plus angle B equal to 180 degrees. Angle B is equal to 180 minus 140. Angle B is equal to 40 degrees. And last MCQ in first main. Here we have to find out ACB. ACB. This angle we have to find out. First what they have given in this diagram, that part we have to see. Here PA tangent of the circle and PB is also tangent of the circle. PA and PB both are equal, it will come. Next we have to draw here join AO and OB. OA means what? Radius, and OB also radius. PB is the tangent. OAB is the radius. Here 90 degrees it will come. Next PA is the tangent. OA is the radius. Here also 90 degrees we will get. Here how much degrees? We have to observe PAOB is a quadrilateral. Sum of all angles in a quadrilateral is 360 degrees. Here quadrilateral PAOB. Angle P plus angle A plus angle O plus angle B is equal to 360 degrees. Here angle P is 70 degrees plus angle A is 90 degrees because here PA is perpendicular to OA and PB is perpendicular to OB. OA comma OB are radial. Here 90 plus angle O we have to find out. Angle B is 90 degrees equal to 360 degrees. Here 70 plus here angle O is equal to 360 minus 90 minus 90 minus 70. All three angles we have to send right side. Angle O is equal to here 360 minus here 0. Here 10, 90, 90, 70. Here 0 it will come 18, 18, 19, 20, 25, 250 it will come. Here angle O is equal to 360 minus 250, 0, 1, 1, 110 degrees it will come. Here 110 degrees, but we need only C angle, ACB angle we have to find out. What property we can use? Circles property we have to use. Angle AOB is equal to double of angle ACB. Angle AOB is equal to 2 into angle ACB. Angle AOB is 110 degrees, 2 into angle ACB. Angle ACB is equal to 110 degree by 2. 2 1 just, 2 5 just 10, 2 5 just. Angle ACB is equal to 55 degrees. Hi everyone. I hope you understand my videos. Please subscribe and share my channel. Let's start next problem. Here radius of the circle is 8 centimeters. Here first we have to draw one circle. This is center of the circle. Radius. This is radius. Radius how many centimeters? 8 centimeters. Here 8 centimeters. Next, find the length of tangents drawn to this circle. Tangent we have to draw here. This is tangent. This length we have to find out. From a point, a distance of 10 centimeters from the center. This is center to tangent. 10 centimeter they have given. This is 10 centimeters. This is O, this is A, this is B. Here AB length, tangent length we have to find out. Here the tangent, AB is the tangent, OA is the radius. Both are perpendicular lines. This is 90 degrees it will come. 90 degrees means Pythagoras theorem we can use. 90 degrees opposite side is the hypotenuse. Here AB is tangent, OA is radius, OA is perpendicular to AB. Angle A is equal to 90 degrees. Pythagoras theorem, triangle AOB, here square of the hypotenuse OB square is equal to OA square plus AB square. Here OB square how much? 10. 10 square is equal to OA how much? 8 centimeters. 8 square. Here AB we have to find out. AB square. 10 square 100 equal to 8 square 64 plus AB square. Here 64 we have to shift left side. AB square is equal to 100 minus 64. AB square is equal to, here 10 minus 4, 6, 36 it will come. 36 is the perfect square. AB square is equal to 6 square. Square cancel it will come. AB is equal to 6 centimeters. AB equal to 6 centimeters. Before going to this problem, I hope you understanding my problems. So please subscribe my channel. Let's see our problem. Here third problem. AB is the tangent. Here AB is the tangent and AB is 15 centimeters they have given. Next AC is 7.5 centimeters. We have to find out radius of this circle. What is the radius here? OC is radius and OB is the radius and OD also radius. These three radius are equal. Here some x we have to take, here also x, here also x. Any one side we have to find out. Now we have to observe what triangle we have to consider here. OBA triangle we have to consider. Here what property, what theorem we have to use. Here 90 degrees where it will come? Radius tangent. This OB is the radius and AB is the tangent. Here is 90 degrees. This OA is the hypotenuse. Pythagoras theorem we have to apply here. Here OB is equal to OC is equal to OD. Some x we have to take radii. Next, AB is equal to 15 centimeters. AC is equal to 7.5 centimeters. Here OB is perpendicular to AB. Angle B is equal to 90 degrees. Pythagoras theorem we have to apply here. Pythagoras theorem, square of the hypotenuse equal to sum of the squares of remaining two sides. Here what is the hypotenuse? OA is the hypotenuse. OA square is equal to here OB square plus here AB square. Here OA, here 7.5 plus x it will come. 7.5 plus x whole square is equal to OB. OB is the x square plus AB. AB is the 15 whole square. Here 7 A plus B whole square formula we have to apply. 7.5 whole square plus x square plus 2 into 7.5 into x plus is equal to x square plus 15 yes 225 it will come. Here x square cancel, remaining 7.5 whole square. 7.5 whole square is equal to 5 5 25.78. Just before a next number we have to multiply 7 8 56. Here 56.25 plus 7.5 into 2 15 it will come. Already we have x is equal to 225. 15x is equal to 56.25 we have to send right side. 225 minus 56.25. Here 225.00 56.25. Here 5. Here 9 minus 2 7 point. Here 14 minus 6 8. Here 11 minus 5 6 1. Here 15x is equal to 168.75. Here x is equal to 168.75 by 15. 15 1 just 15 1 just 15. 15 1 just 15. 15 2 just and 15 5 just. So x is equal to 11.25 centimeter it will come. This is the radius of the circle. Next, fourth main, two circles of radii 5 centimeter, 3 centimeters are concentric. Concentric circles means same radius and different, same center and different radius. Here same center, one center we have to consider. Here 3 centimeter circle, 5 centimeter circle we have to draw. Next, find the length of the chord of outer circle which touches the inner circle. Inner circle we have to touch and outer circle chord we have to draw. This is chord of outer circle and touches the inner circle. Here, this is how much it will come. First circle radius 3 centimeters. Oh, this is 3 centimeters. Next, outer circle from here to here. This is outer. This is radius of the second circle 5 centimeters. A, B, and C. Next, here length of the chord. AC length we have to find out. First you should find out AB. After AB length and BC length both same only. We have to add AB plus BC. AC we will get. Here what theorem we have to find out? What theorem we have to apply here? Pythagoras theorem. Here AB is tangent of the small circle and OB is the radius. Radius tangent always perpendicular. This is 90 degrees. Here triangle ABO. Angle B is 90 degrees. Pythagoras theorem. 90 degrees opposite side. Hypotenuse AO square is equal to OB square plus AB square. Here OA 5 square, OB 3 square plus AB square. Here 25 is equal to 9 plus AB square. AB square is equal to 25 minus 9. Here AB square is equal to 16 it will come. 16 is the perfect square. AB square is equal to 4 square. Square square cancel. AB is equal to 4 centimeters. AB is 4 centimeters. Now we have to find out AC code. AC is equal to AB plus BC we can write. AB is equal to BC we have. So AB how much we got? 4 centimeters. This is 4 centimeters miss. This also 4 centimeter. Both we have to add 4 plus 4, 8 centimeters. Next, fifth problem. Here three circles touch each other externally. Here three circles touching externally. A triangle is formed when the centers of these circles are joined. Here center of the circles, if you will join means triangle it will form. A, B, C. Next, find the radii of the circles. This each circle radius we have to find out. If sides of the triangles formed are 6 centimeter, 8 centimeter, 9 centimeters. Here 6 centimeters, here 9 centimeters, and this is 8 centimeters. Here radius we have to find out. First we have to take C until here. Here some P, Q, or we have to take here CQ and CP. Both are radius only. So these two are equal, it will come. This is x1, this is x1. Both are equal. So this is also x1, it will come. Next, this circle we have to observe AP and AR, both radius only. This is x2, this is x2. Next, here BQ and BR, both radius. These two radius equal. So x3 and this x3. Now we have to observe AC. What we can write? Total is 8 centimeters. Here x1 plus x2 is equal to 8 centimeters. We can write AC is equal to 8 centimeters. Here AC how to write? CP plus AP. CP plus AP is equal to 8 centimeters. Here CP means x1 plus x2 equal to 8 centimeters. Equation 1. In the same way, remaining sides also we have to write. This side how to write? X2 plus x3. X2 plus x3 is equal to 6 centimeters. Equation 2. Next, x1 plus x3. X1 plus x3 is equal to 9 centimeters. Equation 3. First two equations we have to consider. Elimination method we have to use 1 comma 2 equations. X1 plus x2 is equal to 8 centimeters. Here second equation x2, x3 I will write first. Next x2 is equal to 6 centimeters. Elimination method we have to use. Here minus 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 x2 plus x2 minus x2 cancel. Remaining x1 minus x3 is equal to here 2 it will come. This is equation 4. Now we have to take equation 3 and equation 4. Equation 3 and 4 we have to consider. By elimination method we have to do x1 plus x3 is equal to 9. Equation 4 x1 minus x3 is equal to 2. Here plus x3 minus x3 cancel. 2x1 is equal to 11 it will come. x1 is equal to 11 by 2. 2 1 just 2, 5.5 just it will come. 5.5. x1 means what? This circle. See center of the same. This circle radius is 5.5 centimeters. This 5.5 centimeters we have to substitute any one equation here. Either 3 or 4 fourth equation. Here equation 3, x1 plus x3 is equal to 9. Here x1 value is 5.5 plus x3 equal to 9. x3 equal to 9 minus 5.5. Here x3 is equal to, here see 9.0, 5.5. Here 5 it will come 8 minus 3.5 centimeters. x3 value is 5 point, this circle radius is 3.5 centimeters. Next, here x3 substitute, here equation 3, x1 we will get. x1 already finished and x3 also finished. Here equation 1 we have to substitute. Here x1 value substitute equation 1, x1 plus x2 is equal to 8. Here x1 value how much? 5.5 plus x2 is equal to 8. x2 is equal to 8 minus 5.5. x2 is equal to here 8.0, 5.0. Here 10 minus 5, 5. Here 7 minus 5, 2.5 centimeters. x2, x3 and x1. Next, sixth problem. If the sides of a quadrilateral ABCD, this is quadrilateral sides AB, BC, CD and AD they have given, touch a circle. Prove that AB plus CD is equal to BC plus AD. This condition we have to prove. First we have to see AB is touching the circle at P, that we have to take. Here some Q, here R and here S, that we have to consider. First you should observe this one. Here AB is tangent of this circle and AS also tangent of this circle. A is the external point to the circle. So AP is equal to AS, we can write AP comma AS are tangents. AP is equal to AS. Equation 1. Next, BP is equal to BQ. These two are tangents to the circle. Here BP comma BQ are tangents. So BP is equal to BQ. This is equation 2. Next, this side CQ is equal to CR. CQ is equal to CR. Equation 3. Next, dr comma dr and dr ds. ds is equal to dr. Order we have to follow. We have to add all. 1 plus 2 plus 3 plus 4. Here left hand side we have to add AP plus BP. Next this side we have to add CR plus DR. Otherwise I am writing is equal to here AS, here plus BQ, here plus here Q is there. So see Q we have to write. Plus here S is there. That's why S I will write right side only. DS. AP plus BP. We have to observe diagram AP plus BP. What we can write? AB we can write AB plus. Next CR plus DR. CR plus DR. So total CD we can write. CD. Next here AS plus DS. AS plus DS. So AD we can write. AD plus BQ plus CQ. BC. This is our condition, hence proved. Next problem is 7th problem. Here use question number 6. Question number 6 properties we have to use. Prove that parallelogram is ABCD is a parallelogram. Before question number 6, ABCD is a quadrilateral they have given. This parallelogram also quadrilateral only. Here you should feel ABCD is a parallelogram. That we have to prove. ABCD is a rhombus we have to prove. First parallelogram conditions, opposite sides are equal. Rhombus conditions, all sides are equal. So all sides means we have to prove any two sides equal. Here, this condition, question number 6 condition, here AB plus CD is equal to AD plus BC. Here, parallelogram condition, parallelogram, opposite sides are equal. What are the opposite sides here? AB is equal to CD. AB equal to CD. Next, here BC is equal to AD. Substitute here. Here AB is equal to BC. We have to prove. Here instead of CD place, we can write AB. Here AB plus CD. What condition we have? That you should write first. BC. Here AB we want. So instead of CD plus AB, you should write AB plus AB is equal to. Here what we have to prove? BC. So instead of AD plus, you should write BC. BC plus BC. Here 2AB, here 2BC. 2 cancel, AB is equal to BC. In the same thing, here also, here this side we have to take means BC is equal to CD, it will come. Next CD is equal to AD. Therefore, AB is equal to BC is equal to CD is equal to AD. Therefore, ABCD is a rhombus. Next, 8th question. Here prove that AP plus BQ plus CR equal to BP plus CQ plus AR. And also show that two problems they have given here. Second one is AP plus BQ plus CR is equal to half into perimeter of this triangle. Perimeter of triangle means sum of all sides, half. That half also we have to prove. So first prove that this condition. First diagram we have to observe here. Here first this side, B side we have to observe. BQ and BP both are tangents to this circle. So B is the external point to the circle. BQ and BP both are equal, it will come. BP is equal to BQ. Equation 1. Next, C side we have to observe CQ and CR both are equal. CQ is equal to CR. Equation 2. Next, A side we have to observe AP is equal to AR. AP equal to AR. 1 plus 2 plus 3 we have to do. You should observe here LHS AP. First AP we have to take a third equation AP plus next BQ. Here first equation BQ plus CR. Second equation CR. Remaining here already AP finish. Right side AR plus here already BQ first equation. Remaining BP plus here CR already I wrote. Here CQ. Hence proved. Next second one. Second one AP plus BQ plus CR we have to take. This we have to prove. So this equation we have to use. This equation we have to add extra, adding AP plus BQ plus CR on both sides of equation 4. Equation 4, both sides you should add this BQ plus CR plus AP plus BQ plus CR is equal to RHS AR plus BP plus CQ, already equation 4, remaining AP plus BQ plus CR. Here AP terms 2, BQ terms 2, CR terms. Here AP 2 times, BQ 2 times, 3 are 2 times. So 2 we have to take common. AP plus BQ plus CR is equal to, here AR, CR in one bracket, AR plus CR plus here BP plus AP one bracket. Next CQ plus BQ is one bracket. We have to observe in diagram AR plus CR. Total we can write AC plus here BP plus AP means AB plus CQ plus CQ. CQ plus BQ is BC. This two we have to send right side. Here AP plus BQ plus CR is equal to 2 shifting means 1 by 2 it will come. Here AC plus AB plus BC. Here what we can write half into perimeter of triangle ABC, sum of all sides into perimeter of triangle ABC. This is AP plus BQ plus CR. Next, ninth question. Here we have to use question number 8. If AB is equal to AC, then prove that BQ is equal to CQ. This is question number 8 diagram. From this diagram, we have to prove BQ is equal to CQ. Here, already one condition they have given AB is equal to AC. This is equation 1. Next, from this diagram, AP is equal to AR we can write because these two lines are tangents of this circle. AP is equal to AR. Now we have to write 1 minus 2. Equation 1 minus equation 2. What we can write? AB minus AP is equal to AC minus AR. Observe this diagram. AB minus AP. Remaining BP we can write. BP is equal to AC minus AR. CR. But we have to prove BQ is equal to CQ. Here BP plus what we can write? From this side we have to observe BP and BQ both are same because these two are tangents to this circle. Here BQ is equal to CR plus CQ we can write. We should write here BQ is equal to BP. Here CR is equal to CQ. Hence proved. Next, 10th question. 10th question, radii of two circles they have given 6.3 centimeters and 3.6 centimeters. Distance between the two centers we have to find out. The two centers how to find out. Two problems they have given. Here the two circles touch each other externally. See here these two circles are touching externally and these two circles are touching internally. Internally touching these two circles. This distance we have to find out. Here some P we have to take. Here AP distance how much they have given? 6.3 centimeters and PB distance is 3.6 centimeters. AB distance how much it will come? AP plus BP. Here AB is equal to AP plus BP. 6.3 plus 3.6, 9.9 centimeters. This distance. Next, they touch each other internally. Here AB distance is here total distance. This is P we have to take. Total distance is 6.3 centimeters and only BP is the radius of second circle. This distance is 3.6 centimeters. This distance we have to find out. Here distance is equal to AP minus BP. AP 6.3 minus 3.6. Here 2.7. Next 11th question. From a point P outside a circle with center O. Here diagram they didn't give. We have to use this conditions. First point P outside the circle. Circle we have to draw. This is one circle. Outside one point we have to take. That point is P. This is the point P. With center O. This is center O. Tangents PA and PB. From tangents means we have to draw from circle to point. Circle to point we have to draw. This is A and this is B we have to take. And this is radius. This is also radius. First we have to prove AOP is equal to BOP. AOP. One triangle we want. So we have to draw triangle here. We have to observe here how many triangles form. Two triangles, AOP one triangle, BOP two triangles. Here angle equal we have to prove. When we have to prove angle is equal, these two triangles are congruency we have to prove. Congruency proving means corresponding angles equal it will come. First we have to consider triangle AOP comma triangle BOP. So which criteria will satisfy here? First OA and OB both are radius. Both are equal. OA is equal to OB radius. OP is the common side. OP is the common side. Next, here AP and BP are tangents. Both are equal. AP is equal to BP. Tangents. Side, side, side. Here, triangle AOP is congruent to triangle BOP. Side angle, side, side, side criteria. Here we proved congruence. The two triangles are congruency we proved. So corresponding angles equal. Here this angle and this angle equal it will come. Angle AOP is equal to angle BOP. This is the first problem. And second problem is OP. OP is perpendicular bisector of chord AB. Chord AB means this is the triangle. We have to draw one chord here. We have some letter we have to take, some D letter we have to mention. Here we have to take AOD triangle and BOD triangle. These two triangles, congruency we have to prove. Congruency means here OP is perpendicular bisector of chord AB. Here chord AB, OP is perpendicular of chord AB, meaning what? AD is equal to BD we have to prove. So consider triangle AOD, comma triangle BOD. BOD. Here which criteria will satisfy here? OA is equal to OB. OA equal to OB. OD is the common side. OD is the common side. Next, already we proved here angle AOD is equal to angle BOD from first problem. Angle O AOP is equal to angle BOP. First problem. Therefore, triangle AOD congruent to triangle BOD. Here what criteria satisfied? Here side angle. ACS criteria. So corresponding sides are equal, it will come. AD is equal to BD. What we can say? OP is bisecting. OP is bisecting chord AB. Hence note. Next, 12th question. Here two circles touch each other externally at point P. Here AB is the direct common tangent. AB is the direct common tangents of these two circles. Tangent at point P bisect AB. Here P is bisecting AB. That we have to prove. We should draw line here. Should observe here some letter we have to take. Some C letter we have to take. Now what we have to prove? Here PC is bisecting AB. That means AC is equal to BC we have to prove. First one, here AC is equal. Here AC is equal to BC we have to prove. First condition. Next condition, angle APB. APB. This full angle is 90 degrees we have to prove. First, how to do first problem? Here we have to observe only first triangle. Here AC comma PC are tangents of this first circle. Here AC comma PC. Both are tangents. What we can write? AC is equal to PC. Equation 1. Next, second circle. CP is equal to BC. These two lines are tangents to the second circle. Here BC is equal to PC. Equation 2. From equation 1 and 2, what we can say? Right hand side are equal. So left hand side equally we can write AC is equal to BC. Equation 1 comma equation 2 we can write AC equal to BC. Here AC equal to BC. First condition proved. Next, second condition, APB equal to 90 degrees, we have to prove. First, we have to take here. Here AC tangent and PC is the tangent. This is one triangle, ACP triangle. Here two sides equal. So what we can say? Isosceles triangle. These two angles equal we can write. This is equation. This is angle 1. This is angle 2. These two angles equal. Here second problem. Here AC is equal to PC. So opposite angles are equal. Angle A is equal to angle P. P means here angle 1 is equal to angle 2. Easily we can find out this. Next, this side we have to observe here BC comma PC are tangent. These two lines are equal. So these two angles equal it will come. Isosceles triangle. This angle equal. This is angle 3. This is angle 4 we have to write. Here BC is equal to PC. So what we can write? Angle 3 is equal to angle 4. This is equation 3 and this is equation 4. Now we have to consider ABP triangle. Triangle ABP triangle. Sum of all angles are 180 degrees. Angle sum property we have to use. Angle A plus angle P plus angle B is equal to 180 degrees. Here angle A means 1, angle 1 plus angle P means angle 2 plus angle 4 plus angle B is equal to angle 3. 180 degrees. Here what we have to prove? Angle APB. So angle P we have to prove 90 degrees. So angle 2 plus 4 only we need. Instead of angle 1 plus we have to write angle 2. Instead of angle 3 plus we should write angle 4. 2 and 4 only we want. Instead of angle 1 plus we have to write 2. Here equation 3 plus angle 2 plus angle 4 as it is. Instead of angle 3 plus what we can write? Angle 4. 180 degrees. Here how many angle 2's? 2 2's and 2 4's. 2 is the common. Angle 2 plus angle 4 equal to 180 degrees. Angle 2 plus angle 4 equal to 2 we have to shift right side. 180 by 2, 90 degrees. What is this? Angle APB is equal to 90 degrees. Hence proved. Next, for 13th question, tangents AP and AQ are drawn to a circle, center O. Here from an external point A. A is the external point. Here PA and PQ are tangents. OP and OQ are radius. Prove that angle PAQ. Here PAQ. This angle is equal to 2 into OPQ. OPQ. So we have to draw one line here. 2 into this angle. These two angles is equal to we have to prove. So for conditions we have first we have to write OPAQ. This is a quadrilateral. Sum of all angles 360 degrees. Here OP is the radius, PA is the tangent. Radius tangent always perpendicular. This full angle is 90 degrees. Here also this is radius and AQ is tangent. This full angle is 90 degrees. Here OPAQ is a quadrilateral. Sum of all angles 360 degrees. Angle POQ plus angle P full plus angle Q plus angle PAQ is equal to 360 degrees. Here angle POQ plus angle P means 90 degrees plus angle Q full 90 degrees plus angle PAQ is equal to 360 degrees. Angle POQ plus 180 degrees plus angle PAQ is equal to 360 degrees. Angle POQ plus angle PAQ is equal to 360 3 plus 180, shift right side, minus 180. Here 0, 16 minus 8, 8. Here 2 minus 1, 180. Here angle POQ plus angle PAQ is equal to 180 degrees. This is first condition, equation 1. Next, one more condition we want. We have to observe OP comma OQ, both are radius. These two lines are equal. We have to consider OPQ triangle. These two sides are equal, means opposite angles are equal. Angle P and angle Q are equal. Triangle OPQ, angle POQ plus angle OPQ plus angle OQP is equal to 180 degrees. Here what we can write? Here this angle equal. Angle OPQ is equal to angle OQP. Both are equal. We have to apply here. What we need here? OPQ we want, our problem. So instead of this place, we can write left hand side. Angle POQ plus angle OPQ plus this one plus we can write OPQ is equal to 180 degrees. Angle POQ plus here 2 times is there. 2 into OPQ is equal to 180 degrees. Equation 2. We have to observe equation 1 and equation 2. Right hand side 180 degrees. Left hand side equal we can do. Here equation 1 and 2. Angle POQ plus angle PAQ is equal to, this is angle POQ plus 2 into angle OPQ. Here angle POQ cancel. Remaining angle PAQ is equal to 2 into angle OPQ. This is our answer. Hence proved.